Question type. Listen and answer each question. 1.
So traditional telephone cable is made of copper, as we already mentioned. When talking about international communications, those copper wires have to be laid across the ocean floor. An undersea telephone cable has 4 layers: the copper wire that carries the signal, a plastic tube that goes over the copper wire, a steel cable, that one gets wrapped around the wire to provide strength, and then finally a waterproof rope to keep it from rusting. Now, that whole package ends up being about 3 inches wide and weighs as much as 10 tons a mile. And we're talking about laying hundreds or thousands of miles of this stuff. On top of that, they only last 30 or 40 years before they have to be replaced. So, not even counting their much higher bandwidths, do you see why telecommunications companies are willing to pay millions for satellites to handle international calls?
What is the professor's opinion of undersea telephone communications? Two.
One of the most important safety features in a car, even more important than the airbags, is the crumple zone. The crumple zone, actually there's 2 of them, one in the front and one in the rear. Anyway, they're designed to collapse relatively easily in a crash. This allows the crumple zone to absorb all, or at least most of the energy from the crash. That means that the passengers take less of the crash energy and are less likely to be hurt. Now, the major drawback to crumple zones is that they greatly increase the cost of repairs after a crash. Even in a crash at relatively low speeds, where people probably wouldn't be hurt anyway, crumple zones take a lot of damage, and that increases the repair cost greatly. But I guess we should put safety before dollars, huh?
What does the professor think about crumple zones? Three.
How many of you have heard of Moore's Law? No? No one? Okay. Moore's Law states that the processing speed of microprocessors will double roughly every 2 years. Now, so far, Moore's Law has held true. Microprocessors have increased in speed and power at a rapid and steady rate. But now we're running up to the limits of our technology, and computer manufacturers are having trouble keeping up with the predictions of Moore's Law. Today, we're going to talk about why.
Professor, this is the same problem with increasing memory storage, right?
Yes and no. I'm glad you're thinking. But let's just stick to microprocessors for now, okay? Alright, so microprocessors work by having thin wires cut into them so they can transmit electrical signals. The thinner you can make those wires, the more you can put on a microprocessor, and that makes a faster computer.
Listen again to part of the lecture, then answer the question.
Professor, this is the same problem with increasing memory storage, right?
Yes and no. I'm glad you're thinking. But let's just stick to microprocessors for now, okay?
What is the professor's attitude toward the student's question? Listen and answer each question. 4.
MRI technology is essential to modern medicine. It allows us to take extremely detailed images of the body, far more detailed than those of, say, X-rays. Now, MRIs work basically through super powerful magnets. Now, when I said the magnets are powerful, I meant it. So powerful they can be dangerous. All metal has to be removed from the patient, belt buckles, change in their pockets, anything. It's all got to go before the patient enters the MRI room. But MRI technology has been spreading so fast that not all the nurses and technicians who work with it are properly trained. Sometimes less obvious sources of metal. Let's say the patient has a metal pin in their leg from surgery. Sometimes that kind of stuff is overlooked. And well, if you got a piece of metal inside your body and you're near a really powerful magnet.
How does the professor feel about MRI technology? 5.
The famous architect Frank Lloyd Wright said that form follows function. What he meant was that style and design are important, but they should always make a product more useful, or at least they shouldn't make it less useful. We use that same philosophy in product design. Look at cell phones or laptop computers. The designs for these have gotten smaller and smaller, right? And what's the function of these machines? They're supposed to be portable, so a smaller size makes them more functional.
Yeah, but isn't there a limit to that? Some cell phones are so small now that it's hard to press the right buttons.
Sure, good point. In that case, design has started to interfere with function, and if you have noticed, some newer cell phones have actually gotten a bit bigger in the last year or so.
What is the student's attitude toward the design of smaller electronics? Six.
We all know that the world is facing an energy crisis. Even if our supplies of oil and coal weren't limited, the pollution they create is severe. And nuclear power isn't much better. Nuclear waste has to be stored for thousands of years, and we don't have any good answers for long-term storage as of yet. So the obvious answer is that we have to find a way to exploit other energy sources. We do this on a limited scale already. We have hydroelectric dams, windmills, a bit of solar power. But none of these technologies produce nearly enough power to totally replace oil and coal. Okay, in theory there is enough energy from the sun to supply all our power needs, but reality almost never lives up to theory. At best, these will probably represent secondary sources of power.
Listen again to part of the lecture. Then answer the question.
Okay. In theory, there is enough energy from the sun to supply all our power needs, but reality almost never lives up to theory.
What is the professor's opinion of solar energy? Exercise 1. Listen and choose the best answers.
Nanotechnology is definitely the up-and-coming field in materials development. Nanotechnology, the creation of materials or machines that are only a few atoms in size, presents a whole new range of possibilities. There are many reasons for this. For one thing, many materials, when they get down to this size, they have fundamentally different properties than they do at larger sizes. A good example would be buckyballs. These are collections of carbon atoms, but the way they arrange themselves, they form an extremely strong structure, much stronger than carbon normally does. That has obvious advantages, right? Other uses for nanotechnology are farther off in the future. There's a lot of talk about making nanorobots, but that kind of thing is still decades away. You've probably heard all of that before, given nanotechnology's wide coverage in the press. But here's maybe something that maybe you haven't heard in the news. One of the catches to nanotechnology is that particles at this size can enter our cells. They're so small they can just pass right through the protective walls of our cells. And what they do once they're inside, well, that's anyone's guess. You know, it reminds me a lot of the explosion in pharmaceutical technology 50 years ago. At the time, advances in chemistry were fueling the development of entire new classes of drugs, and a lot of those drugs turned out later to have unintended and unforeseen effects.
1. What is the main topic of the lecture? Two. What is true of nano-sized materials? Three. What is the professor's attitude towards nanotechnology? Exercise 2. Listen and choose the best answers.
Let's talk about a piece of technology that has gone through a dramatic change, all due to the younger generation and their love of music. I'm talking about portable music players. I'm sure that most of you here have one. Many are even built right into mobile phones. Listening to music on the move has sure come a long way. It is safe to say that portable music was possible due to an electronics giant, Sony. In 1979, Sony produced the Walkman that played cassette tapes and had very basic functions, and for about 15 years, not much changed. This was due to the fact that a better medium was never adopted or popularized enough to take over cassette tapes. Enter compact discs, or CDs. CDs were a huge step above cassette tapes. Unlike cassette tapes, they do not deteriorate, have no moving parts, and theoretically last a lifetime. However, the players themselves were as large as CDs, which have a standard size of 12 centimeters. The players also needed a lot of power and often skipped when shaken hard. Later models had anti-skipping technology, but it was still not small enough to fit in a standard breast pocket. The technology boom in the 90s introduced MP3 format to the world. Soon, the first 32-megabyte MP3 player was introduced by a Korean company called Sehan in 1998. While some players use smaller and larger capacity hard disks as data storage, most MP3 players utilize flash chips instead. Although chips can't store as much as hard disks, the benefits far outweigh the drawbacks of hard disks. Chips are small, cheap, unaffected by shocks, and continue to grow in storage capacity. Current robust chips can store 1 gigabyte and 2 gigabytes of memory, or hundreds of songs.
1. What is the lecture mainly about? 2. According to the lecture, what was the problem with cassette tapes? 3. Listen again to part of the lecture, then answer the question.
While some players use smaller and larger capacity hard disks as data storage, most MP3 players utilize flash chips instead. Although chips can't store as much as hard disks, the benefits far outweigh the drawbacks of hard disks. Chips are small, cheap, unaffected by shocks, and continue to grow in storage capacity.
What does the professor mean when she says this?
Although chips can't store as much as hard disks, the benefits far outweigh the drawbacks of hard disks.
IBT practice. Listen to part of a lecture in a technology class. The professor is talking about wireless technology.
Someday, and someday not so far away, it will seem like an old-fashioned idea to have to plug in a laptop. It will just seem normal that your cell phone will interact with all your other appliances, and appliances interact with you. In fact, the whole idea of wires will be considered outdated. And remember, I said that this is something that will come in the near future. So today I'd like to talk a little about wireless technology, how it works, and where it will take us. Now you may think that wireless technology is a new idea. In fact, it's actually quite old. When you listen to a radio or watch TV, you're taking advantage of wireless technology. You see, we're surrounded all the time by invisible waves, all carrying information. There are TV and radio signals, cell phone and other communication signals. They're all there all the time. You just need the proper device to interpret them, okay? To translate these signals into some meaning, radios and cell phones kind of decode them into sounds, and TVs into sounds and pictures. Okay, I think it's a good idea to break wireless communication into two types. Local and wide area. Now, local wireless signals can be used to, say, make a toy car move around or open your garage door. Such wireless communication only operates over a few meters. A cell phone, on the other hand, can connect you to any place on the planet. But the truth is that your cell phone, even though it's considered a wide-area device, has no more power than one of these toys or your garage door opener. The secret to it is that it uses a network of land-based communication helpers that are generally known as cell phone towers. By placing them at appropriate distances, it is possible to use a little power to create a signal that can be sent a long way. You can use your cell phone as long as you are within range of one of these towers. Actually, when you pay your phone bill, you're paying to use the network of towers that has been set up by a particular company. I've probably been focusing a little too much on cell phones today. In the future, nearly everything you buy will contain a small chip which will allow you to interact with it. The food you buy will wirelessly talk to your refrigerator, which in turn will talk to you. Yeah, I know this sounds weird, but what I mean is, you can ask your refrigerator, for example, what the expiration date is for certain products, or how many calories are in your snack. That kind of thing. Your mirror could tell you the weather. And all TVs will be wirelessly connected to the internet. And the interesting thing is that all of these products I've just mentioned are currently being produced as I said. The wireless future is right around the corner.
Now get ready to answer the questions. You may use your notes to help you answer. 1. What is the main idea of this lecture? 2. What does the professor say about wide-area wireless cell phones? 3. Why does the professor mention toy cars and garage door openers? 4. Listen again to part of the lecture, then answer the question.
And remember, I said that this is something that will come in the near future. So today I'd like to talk a little about wireless technology, how it works, and where it will take us.
Why does the professor say this?
And remember, I said that this is something that will come in the near future.
Five. Listen again to part of the lecture, then answer the question.
I've probably been focusing a little too much on cell phones today. In the future, nearly everything you buy will contain a small chip which will allow you to interact with it.
What does the professor imply when he says this?
I've probably been focusing a little too much on cell phones today.